Hello everyone, I am TANISH RAINA and I am going to introduce you to our project. Our model name is Temperature and Air Quality Sensor. We are team number 29 with members TANISH RAINA, VISHAL Raj and Tushar Kumar. So what is the aim of our project? The aim of our project is to measure the temperature and humidity of a region, giving accurate readings with minimal amount of error. We have made it very compact so that it can be carried anywhere easily. It gives very fast readings and can give readings each and every second. So this can be used to measure the temperature of our surroundings like our home or outdoors wherever we travel. It can also measure the humidity of the region, which gives us the analysis of the air quality. Since high humidity is usually, it tends to have high rates of harmful and toxic chemicals and harmful pathogens like viruses and bacteria, which can cause respiratory infections. So by giving the humidity, we can actually control the air quality in our homes. So what are the main components of our project? The first component is the DST level sensor. It can do two jobs at once, and by giving the temperature and humidity both together. It is very small in size, which helps us to make our project very compact. The next component of a project is the I2C module. The I2C module converts serial data to parallel data in an LCD display. It basically reduces the number of connections required to given to the LCD significantly from 16 to just 4. This is permanently attached to the LCD and all the connections to the LCD are made through this module. Next we have the LCD display, which gives us the readings of the project in a suitable and easy manner. Next we have the Arduino Uno, which is the very important component of our project. It, as we know, it is a microcontroller. It enables us to program our model and connect them to various LCDs and sensors. Now this is the circuit diagram of our project. We wanted to make this on a software, but unfortunately the sensors were not available on almost any softwares, and hence we had to make it on paper. So highlighting some of the important connections, we have the connection from the output terminal of the DS211 sensor to the Arduino board's second digital pin. We have the 5-volt terminal of the Arduino Uno connected to the breadboard along with the positive terminal of the DST11 sensor and the VCC terminal of the I2C module. Here we are using the breadboard since there is only one 5-volt terminal, and hence we need a breadboard to connect it to both the I2C module and the DS211 sensor. Next we have the negative terminal of the DS211 sensor and the ground terminal of the I2C11 module, both connected to the two ground terminals of the Arduino. We also have the SDA and SCL connected to the A5 and A4 analog pins respectively. Completes our circuit diagram. This is how the circuit actually looks like. This is what our final model looks like. It is very compact and can be easily carried anywhere. Now I would like my friend Tushar to explain the programming part of our software model.
So let us start with the code. First of all, I would like we will create our library for all our sensors starting from ESP8266 for Wi-Fi, for wire, for Adafruit sensor, for Adafruit BM80 sensor, for MQ135 sensor, sample DHT sensor, and liquid crystal I2C sensor. Now we'll create the main library for Arduino, and now we proceed further to define our plugins for all our sensor D1, D2, D4, D3, and respective value 5, 4, 2, and 0. Now we are going to assign the SPI bus to the pin and assign all the above plugins to the main sensor. These are the respective value which we are assigning to the sensor. Now we are going to assign the sea level pressure, which is sea level pressure dot HPA, which is 1013 normal. And now we are going to assign all the data types to the sensors, starting from the float, which is HTP, pin, and DP. Now we assign the character value to temperature F string, DP string, humidity string, pressure string, and pressure end string. Now we will further to assign mm, the API key and SSID and password of our Wi-Fi. Now we go further and we assign the character and assign the server value, which is the following. Now we will go further to the DHT11 sensor, which we assign the data type integer, and we assign the resolution for our LCD screen which we are using. So now we go further to the void setup code. So we will first code for the serial begin. So s.begin 115200, which will allow the Arduino to receive the command through USB cable. Now the delay command, which will take the Arduino for 10 milliseconds to check the code. Now further we go to the serial.println. If everything is good, then it will show to the connecting to SSID. Now we will check further that whether the Wi-Fi has been connected or not. For this we use the while loop. So while inside the while loop, we check the condition if Wi-Fi status is connected or not. If there is any delay or the success, then it will print that Wi-Fi is connected. But if there is any problem relating to the connection, then it will recheck. If VME.begin is not true, then it will print could not find a valid sensor due to some wiring problem, or any other problem can also, and then it will return back. Now we go further and it for the serial.begin, that is used for our another sensor. So now we are going to get into void loop code. So now we use all our sensor to get the reading which will be used to display. The first is MQ135 gas sensor. Then we assign the float data type to air quality, and it will store the value in ppm. Then further it will print the air quality value after storing it, and also the ppm value respectively. Now further we are going to assign the data type to our various parameters starting from humidity. The code is vme.red humidity. Then for the temperature for the same, and we have get the formula for temperature also that convert it into Kelvin. Then dp formula which is assigned. Then further we have the pressure which equals to vme.r, which store the value. Then the formula of pin is this. And now further going d stop, which will store the value in the server for the temperature, humidity, pressure, and pressure range, and dp string respectively. Then the store value will use to print into the LCD screen from temperature F string, to humidity string, pressure string, pressure range, and pressure range string, dew point, and dp string respectively. Now going to serial print line. So now we will code so that the data we get can store to a server in the cloud storage. For this, we make the string post string equals to API key. Then further down, we will store all the parameters as that air quality, pressure string, humidity string, pressure inch string, and temperature F string value to store in our cloud server. So going down, after storing the value in cloud, the client can print out anything with acquired by him, and the further thing will be displayed, such as host.api thing, connection.close, x thing speak, API key, content type, content length, and post string length, and further down post string value will be displayed. Now we go down to our serial println, and which will display sample DHT11, which is a sensor used. Now we will assign the data type to temperature, which is bit, and we store the value 0 initial value, to humidity and temperature 0 and 0. Now we assign make an ERR and assign data type int, and which will contain simple DHT error, and if there everything is right, then it will success. So, and if there is any problem, then the fail, then there will be a message that DTH11 failed will be displayed on the screen. And further we going on the LCD display, and let take make a LCD.begin. After that, we make another code LCD.backlight, which will print temperature, and let make another let LCD.set cursor 0, 1. Then this will display humidity, and the humidity will be in integer format. Now going down, we make check value, which we assign a data type char to it. Then initializing receiver flag 0 and receive some 0 to both, and we start make a loop, for loop for it, in which initial value is 0, and it will go up to length which we have, which it take -2, and it will receive some, and it will display all the things which we wanted, uh, and it will apply all the formula which has been given to it. If everything is right, then everything will be displayed from temperature to humidity, which we all wanted. Thank you.
These are the components that has already been assembled together using jumper wires. These components are DHT11 sensor, Arduino Uno board, I2C module and LCD display of 16:2 that has been soldered together, and a breadboard. In this, using jumper wires, we connected the negative pin of DHT11 sensor to the GND pin on Arduino, and after that the out pin on DHT11 sensor to the 2 pin on the Arduino. Now before connecting the positive pin of DHT11 sensor to Arduino, we have to connect the 5V pin of Arduino to the breadboard, as we have two components, that is DHT11 sensor and I2C module, that will use 5V pin connection of Arduino. So in order to use this 5V pin connection for both the components, we have to connect the 5V pin of Arduino to the breadboard. After that, we connected the positive pin of DHT sensor to the breadboard to a point right next to the point used for 5V pin connection of the Arduino. This is the green wire that of DHT11 sensor, and this is the orange wire that has been connected here on the breadboard. Now with this, the DHT11 sensors connections are complete. After that, we have 4 more connections with the I2C module that has been soldered together with LCD display. These connections are as followed: GND pin of I2C module to the Arduino point on Arduino, and VCC pin of the I2C module to the point on breadboard that is right next to the 5V pin, that is this yellow colored wire that is connected right next to the 5V pin connection on breadboard. And after that, we have 2 more connections, that is SDA and SCL of I2C module to the A5 and A4 point on the Arduino here, that is right on this brown wire. With this, our connection is complete, and the code has already been explained, so all is left to do is to upload the code. But before that, this is the LCD display that was working while we were shooting this video, but it suddenly stopped working, and we have tried everything, and it hasn't worked since then. So the deadline of the project is near, so we are just moving on with it. These are the readings which were taken after uploading the code. And here, after taking the project outside, there was a slight change in the humidity that increased from 74 to 95. In this is the final product that we have created, and it has an integrated Wi-Fi module, and it was made highly portable by connecting a battery to it. An app can also be created which can show the values on a person's mobile phone. Unfortunately, its LCD display stopped working. It got affected somehow, although it was showing the values before that, and we tried it again and again, but the end result was same. And also there wasn't enough time to buy another LCD display as the deadline was near. But we have already shown its working of the project earlier in the video using the laptop.
In the end, I would like to give the contribution by each teammate. This is the contribution by TANISH RAINA. This is the contribution by Tushar Kumar. This is the contribution by VISHAL Raj. In the end, I would like to thank my teachers for giving us the opportunity to work on this project. We certainly learned a lot while making this project. So thank you for watching our video. We hope we were able to give a great insight and understanding to our project by this video. Thank you for watching.